Here's a few news articles that are good. This is a fun one. If you don't remember all these Windows sounds, they've accumulated them all here. All the old versions. Anyway, that's good, clean fun. Yeah, Star Trek is now free for a few weeks or something. So that's interesting. Maybe I'll look at it. I wasn't interested in subscribing to a new channel, but apparently they're making it free with a code gift for some period of time until April 23rd, which I guess is a couple weeks. So that might be fun. The Signal is threatening to leave the US market if the anti-encryption bill passes. This is the Earn It bill, and that's one that we've discussed before. I'm not quite sure what to make of it. The point of the Earn It bill is that if you encrypt your stuff so the government cannot inspect it, then you are no longer protected by safe harbor. So basically, the point is you would then have to, as a company, accept liability if you let horrible things on there like child pornography. So the encryption people are freaking out. I certainly can see some sense in that. But other people are saying in practice, when the government does this, what people do is they lower their encryption to get the legal protection, and then ordinary users are more at risk. So that is another good argument. This does seem to create a financial incentive for companies to avoid using encryption, and that would seem to be a bad thing. So anyway, we'll see what comes of it all. There's free autopsy training if you want it. Autopsy is the open source forensic toolkit. It is the open source alternative to the very expensive products FTK and Encase, and there is a free training offer available. So that's a good thing to know if you want to try that. I know we covered it to some extent here in our class, but there must be quite a bit more to autopsy than a little bit I used to cover in that course, in our forensics course. This lock company is in trouble. They are being, the FTC is considering punishing them because their locks are not secure. They advertised that their locks were unhackable, and nobody should ever say that, but I thought this was pretty good. So this is the lawyer.
Unfortunately, this has been sitting on my back burner.
Well, I don't think I'll play the video. It's a fingerprint lock, fingerprint sensitive lock, which is the idea. You project your fingerprint and then opens the lock. But what this guy did was take it apart, and he found that the mechanism is got a little movable part, and that movable part is magnetic. So all he has to do is get a powerful magnet and sweep it across a few times, and the powerful magnet will jar that piece loose. So that's all you got to do to open it without the key. This is sort of like the master lock padlocks, where all you have to do is hit it the right way with the hammer. It'll just pop open. Most everything that claims to be unhackable turns out to be like this. Anybody that would call their product unhackable is obviously an idiot. They just don't know what hackers are like. If you know anything about security, you never say things like that. You say it resists a certain attack, it is better than the other product, something like that. But you can't say it's unhackable. Anything can be hacked. So Google is banning its employees from using Zoom. Many people are freaking out about Zoom. Zoom has some vulnerabilities. I haven't got excited about it enough to stop using Zoom. But Google, of course, has actually a very standard corporate statement here. They say we've long had a policy of not allowing employees to use unapproved apps. This, I think, dates back to the time when they got hacked, I think in 2000 or 2010. They got hacked because somebody clicked on an email link and they were using Internet Explorer. And then everyone said, why weren't you using Chrome? And Google said, yeah, as a matter of fact, we're going to change our policy to where you have to use Google products when you're doing official Google business, which would seem to make sense because they control the security of their own products. And so it kind of makes sense that they would expect their employees to use whatever the Google product is, Google Hangouts or something. Unless there's a real need for Zoom, you should probably have an official rule of using your official product. Anyway, there's someone sent me this, and it's very nice. New pictures of Jupiter. And these are really good pictures of Jupiter, far better than ones I've seen before. Very interesting. Detailed pictures of the clouds, so I think it's great. Anyway, check that out if you're interested in astronomy. Much prettier than any pictures I've seen before of Jupiter. A lot of people, including me, thought coronavirus would pretty much calm down in the warm weather, but apparently this is not true. Other countries have already moved into the warm weather season, and that did not stop the coronavirus. So that's bad. This, among other things, this is pretty bad looking for DEF CON. I was thinking that perhaps in the summer in Vegas there wouldn't be a problem, but maybe there will. So that's not good. And CVS and Walgreens are opening drive-through coronavirus testing. So it sounds good, although as far as I can tell, there are none of these in California yet, but they're spreading out through more locations, and they have you administer your own test with a swab. That way the people delivering the products do not have to be exposed to the virus. Drive-through testing is by far the best way to do it, because then you don't have to have some kind of doctor's office where a bunch of sick people go in and you have to keep disinfecting it, or people are going to get sick. This way everybody stays in their own car, so they're already pretty much isolated from other people. You just swab your throat or something, put it back in the jar and give it to them, and they use the fast test. It gives you the results in half an hour or so you don't have to wait days for the results. It sounds pretty good. The thing I noticed here is they don't appear to have the antibody test, which is the one I would like, and it isn't happening in California yet. But still, it's good to see testing rolling out. A great many people would like to know if they've got it, know if they've had it, and it is very frustrating that there aren't enough tests out there. The midterm grades were due yesterday, so you'll find your midterm grade in the Canvas, and I suppose the college itself will inform you in the fullness of time. And students already asked me about the final grades, so I put in the calculation of final grades too in Canvas for this course, and I'll put it in the others, which does make sense, because one of the strange things about the structure of college timing is that midterms is not in the middle at all. Midterms is about 80% of the way through. So you've already had quizzes up through 10, and there's only 13 quizzes, and only a few more projects to go. So really, it's a lot more than halfway through. But anyway, there's still time to catch up if you're behind on things, and there is a final exam at the end. Anyway, so I noticed, by the way, Project 14 wasn't due any time, so I made it due next week. Anyway, all right. So let's take a look at the lesson today, which is from the textbook, and this is application logic. Now, this is a very important type of vulnerability, but it's a lot less of a cookie cutter thing than the previous ones, and I'm going to make it bigger, but not quite that big, because then it's hard to point to, and it also goes off to the wrong screen, so it doesn't get caught by the zoom. So these are logic flaws where you make some kind of assumption that leads to an exploitation path, but it's not simple and obvious. This is why you really need an experienced human tester to detect these. So here are some real case histories from applications analyzed by your textbook author. So here, when you click the Remember Me button when you log in, which almost everybody has, so you don't have to keep typing in your password, it's going to store some kind of cookie on the machine that records who you are. Now, one thing people did, which is not a good idea, is they put real data in there, name, user identity in an encrypted string, and the screen name is also saved as an encrypted form. Now, the problem with that is this means I can give myself a name, and the computer will encrypt it and put it in a cookie, which I can see. So I now have access to their encryption routine. Now, I probably don't have the key, and they might very well be using some strong encryption like AES, so I can never figure out what the key is, but I don't necessarily need the key. This means I can feed in arbitrary data, and it will encrypt it for me, and I can see the encrypted result. And therefore, if the encryption is used somewhere else, and it uses the same key, which it might very well, because they might well have written just one encryption routine and use it for many purposes, then I will be able to create my own cookie. So you copy the Remember Me cookie into the screen name cookie, and since it not only, in this case, not only does it encrypt, but it decrypts. It takes the encrypted cookie and decrypts it to show your screen name. So you can take the cookie and decrypt it, and then you'll see what it is, and it has your name, and it looks like some kind of IP address or something. So you can just change your screen name to something else and encrypt it. And you can use the access they have to the encryption to create an encrypted cookie, which will make you identified as the administrator. So this is quite reasonable, and you'll see a whole lot of these happen the same way. Somebody writes a routine which makes sense in one context, but that routine is later used in a different context outside what the original person was thinking of. This is what almost all bugs come from. The developer makes some kind of assumption, and at some point in the future, that assumption is not true. So that's the game. Look for things that are encrypted, try to find other encrypted values and substitute them in, and see if you can cause an interesting error. All right, and then there's a password change function. A typical password change function will ask you for your username, the old password, and the new password. However, the administrator is going to have a form that lets them change a password without knowing the old password. And in this case, in this app, what happened is if the request came in without an existing password to the same function, they interpreted that as proof that it came from the administrator. So because the administrator's page they're looking at did not ask for the old password. This is the same problem we've seen all through this course. Developers think that because they don't put a form on the page you can see, that nobody can submit information in that field. They don't think about people that are using burp and adding or subtracting fields independent of the structure of the page. So the fact that the administrator page doesn't have a password and that the other page does have an old password field makes the developer think that's the only clue they need to know if you're the administrator or not, when of course it isn't. So you can take the non-administrator page, remove the old password field in burp, and now it will interpret you as being the administrator. This is a failure to actually monitor sessions properly. Obviously, they should have some authentication system that really finds out if you're the administrator. They shouldn't take some kind of secondary weak data like that and use it to deduce that you're the administrator. So anyway, this really happened to AOL. All these are real, I think. So try deleting parameters and see what happens, and find out what happens. Delete the name, delete the value, and see if interesting things happen when some of the parameters are missing. So here's one we've talked about in various versions many times. If you have a multi-step process, so you put things in the shopping basket, you finalize the order, you enter payment information, you enter delivery information. It's intended to go in this order, but unless you use a hidden field or some other mechanism to enforce that they really go through these 4 steps in order, then people can skip. So proceed directly from step 2 to step 4, and then they can take a product and ship it without actually paying for it. This kind of thing happens a lot. So you try skipping stages, doing things more than once, out of order, and see what happens. Guess the assumptions and violate them. Like I say, it's a matter of experience to know how to do this. So here's one where you can get a quote for insurance, and then you can submit an insurance application. So you tell about your amount of money you make or something, and it calculates values. And then you supply other personal detail. And then the application is sent to an underwriter, who is a financial analyst sort, who then decides whether they believe you can get the insurance and how much to charge you for it. And this all goes back into the system. And they didn't consider a user that submitted extra parameters. What happened is multiple users are using the same structure. The original applicant is putting data in the structure. Then the third-party underwriter is putting more data in the same structure. And they didn't keep track of who was doing what, just like the first one we talked about. So what you could do is you could do cross-site scripting to find about other people. And you could also modify things. For example, the underwriter could change a field to say this person is a bad financial risk, don't give them the insurance, but the attacker could add those fields and put in that data. And since it didn't keep track of who was putting in the data, it would think the underwriter had put in that data. We've seen quite a few flaws that work this way. All right, so you take parameters from one stage, add them to another, take parameters from one type of user and put them in a different type of user and see if they're accepted. I think the general structure of everything we talked about in this course is clear. It would be nice to think that the system works like, say, your Windows machine when you log in. You log in as one user and it knows who you are. Every process you launch is identified by your name and knows what you're allowed to do. If you log in as another user, it knows who they are all the time they work. But web applications are typically much sloppier than this. Now, if you wanted to get a Orange Book, military certification of security, we talked about this in like the management classes, you have to have something called a reference monitor. You have to prove that you really do have a system that really keeps track of who you are and really makes sure that you're allowed to do what you're supposed to be doing at all the stages. But it looks to me like most web apps are not at all up to that level of security. And it would be a good idea if they were, which is why getting a compliance for your company, being some kind of standard, is a very good step in maturity. Anyway, so here's a bank. You could sign up for online banking, and it collects some information, then it mails an application back to you in paper, which gives you information to log in. So they thought that was safe, and they sent a secret one-time password to you, and you had to call in. So it seems pretty good, but there's a data structure here with information. And the problem is they used the same data when you're registering as when you got in. And they used the same customer number. This is like the one we talked about before called session fixation, where a session value is used for an unauthenticated session, and then the same value is used for an authenticated session. And that's a risk. And here's essentially the same point. They use the same data object for both. So you log in with valid credentials, then you go to the registration function and try to register a new account for a different customer. It will now overwrite the object. And when you return to the main application functionality, you'll now be the other person. So you can confuse the registering a new account with accessing an existing account and get horizontal privilege escalation, where you move from one user's account to another. So that's the fundamental flaw. There are two ways to write to the object. One way you can write information to it after you've authenticated, and another when you're registering. So that's a little convoluted, but it's certainly more and more the same issue. The whole point of web apps is they don't really keep track of who you are all the time frequently. They don't properly keep track of who you are and constantly check to make sure that you're allowed to do what you're doing. They're sort of sprawling systems with a lot of much simpler techniques to figure out who you are that are easily fooled. So here's a business limit. This makes me think of, I think, Jerome Carviel, the famous guy who lost billions of dollars at his investment company by doing essentially this. So you're only allowed to perform transfers of a certain size. And to get larger transfers, you have to have manager's approval. But the code just looks like this. You have an integer variable with the amount. If the amount is less than the threshold, then it doesn't require approval. Otherwise, it's true. So the problem is a plain integer variable has a maximum value, and if you go above the maximum value, it rolls over like an odometer and becomes negative. So all you have to do is put in a really large negative amount, and that will be interpreted as a positive amount. So a negative amount will not require approval. It's below 10,000, but it actually will either move money in the opposite direction, or it will roll over and be interpreted as a positive amount. This is the problem with computer integer variables. A lot of programmers don't understand these have only so many bits, and they roll over like an odometer. There was a cryptocurrency hack like this, something called Ponzi coin that was designed by some users of 4chan as a joke. People put $1 million in it, and someone used this technique to subtract $1 from an empty account, which caused it to roll over and have a giant positive number, and they stole all the money. Anyway, so this is true of numerical limits. If you have only so many units, only certain amount of bill payments and ages and stuff, you can put negative values or gigantic values in all these fields, and they may have unexpected results if the users are not careful with the type of variables they're using, if the developers aren't. Then there's bulk discounts. There are so many of these. Remember, Microsoft had one a few years ago where you could sign up for something and get a flash drive, and all you had to do was use more email addresses or Tor or use Burp or something. You could just get an unlimited number of free giveaways. This happens a lot. So here's an example. If you buy several products together, you get a discount. So there are often ways to fool it. One simple way to fool it is to add all the items to your shopping basket, get the discount, and then delete some of the items out of the basket, and you will forget to remove the discount. All these are showing the same kind of sloppy programming. All right, where you just make it work in the normal case and you don't consider the edge cases. All right, then this one I think is how you do one of like the last challenge in the logic flaws page. It's close to it. Here you've got a web interface that removes special characters to avoid cross-site scripting and SQL injection and such. So they get rid of a semicolon and the pipe and the ampersand. Looks like they're trying to stop code injection like we had in the ping form. But the thing they forgot was to escape the escape character. So if I were to put in a semicolon ls, it would remove the semicolon. But if I put in escape semicolon, then the application will add another escape character to get rid of the semicolon, and that will have the opposite effect. This escape will cancel that escape, and now the semicolon will get in. So this is the fundamental problem with blacklisting. If you try to list all the possible bad characters and then remove them, you are likely to miss something. It is much safer if you list only the good characters and remove everything that is not known good. Whitelisting is much safer than blacklisting. All right. And then there's the input validation system, which does the double quote trick. If you, what the correct way to add a quote in SQL and many other languages is to have a double quote. So if I inject admin apostrophe dash dash, it will put in admin double apostrophe dash dash, and this will be interpreted as an apostrophe stored. So it will look for this literal name, admin apostrophe dash dash. It will not misinterpret it as the start of a comment and let me perform SQL injection. So it looks like this doubling of apostrophes is preventing SQL injection. But the problem is it also had a length limitation in the field. So all you have to do is carefully add enough junk and put the apostrophe at the end so it hits the length limit. So when the app adds the extra apostrophe, it gets cut off by the length limit, and now you can create the SQL injection. So this is very often the case that one security measure undoes the action of a previous security measure. All right. So here's a way to look for it. Submit long strings of apostrophes, see if you can get a syntax error. That's the kiss of death. And then there's a search function here. There are quite a few of these where you can deduce secret data with something like a search function. So here, they got an archive of articles, and only paying subscribers can see the articles, but you can perform a search engine, and it will let you see if there are articles on the topic you're interested in, and then when you try to read them, it will say you have to pay to read them. So that would seem to be a pretty good way to design it. But that means if you guess the title of an article, if you guess it carefully, you can get in. And this is what Arjav came to my Saturday class a few weeks ago. He was able to see presidential polls several hours before they were supposed to be out because he was able to guess the URL and see them. And big companies like CNN were putting up polls on public-facing web servers and just not publishing links to them until later. So they didn't actually make them unreadable until the time. They would just put them up and assume nobody would find them. But of course, the names are predictable and pretty easily found. So if you can guess the name, you can then find a match so you can find the title of an article this way. And of course, you could write a script that will go through things. So they've tried this sort of thing to get a password, try these searches. This one is not found. This one is found. So that means it starts with B. Then you try B, A, B, B, and so on. It won't take an infinite number of guesses to deduce the password. All right, and then there's debug messages and logs. This is commonly a problem. So you have an error message that's got all sorts of information, including the parameters and a token. This is something you'll see if you're having trouble with an app or if it's new and you're trying to test it. The first thing people might assume is it doesn't matter because all you're going to see is your own request. But of course, as we've been saying, the structure of web apps is often the case that it is not true that every server has a proper identity token to know who you are all the time. And of course, in this case, the log was not session-based. So log was just a file publicly viewable that did not know who you were. So you can see other people's error messages. And now you can therefore see other people's parameters and cookies. That's the fundamental problem. All right. So in one place, there is a race condition, but the more interesting thing is you can now see results. All right. And then there's racing against the login. This is something people see pretty often. They design an app, they put it in a limited server, they test it, it seems to be fine. Then when they actually deploy it in production, it has problems which they couldn't see in a test without much load because they were doing something that was risky, but that would only fail under high load. So here, you have a login process and people thought it was fine, but they observed that sometimes customers would see other customers' accounts. And by the way, I've seen reports of this down through the years on Twitter and elsewhere, where people said, I opened my phone, I looked at my Gmail, and it was somebody else's Gmail. And I don't think they're making it up. This can happen. This can pretty easily happen. It means somewhere there was a cache and it decided that you just wanted to see the existing data from a cache instead of the real data from the server or something like that. This happened to Google about 10 years ago. They wanted to offer a free Wi-Fi service, and it was a Wi-Fi accelerator service, and they rolled it out, and a bunch of people said they could see other people's pages. And Google said this was because companies weren't obeying the standards correctly. There were headers that were supposed to be in pages to tell them whether to cache it or not that were not set correctly. So their servers were caching content. Google said, you could argue it wasn't their fault. They said, we were obeying the rules, and these servers are not obeying the rules, but in fact rolled back their wireless product and quit deploying it because it wasn't safe enough to use in the reality of the internet. Anyway, so here you'd see another user's account, and the point is it stored information about the user somewhere, like a temporary file. And then it was read back later, so this is a classic race condition. Each user logs in, it stores your session ID somewhere, then it reads it back. But if another user logs in a fraction of a second later, then their user ID gets written in that file between the time of check and the time of use. That's called TOC/TOU vulnerability. So if too many users use it all at once, there's a chance that your app will read it and some other process has changed it before you went there. So that's a race condition. You can exploit it by winning the race. All right, so if you want to avoid these things, you just have to have a clear logical path through your app, which is quite a challenge. It's the same thing as your business logic, and it really doesn't, it is in no way specific to web apps. There's a human-oriented version of this, which is big now. You send an email to a company and you say, you forgot to pay this bill. Please send a bunch of money to this address. Or you even make it look like that came from a manager or something. And the company's financial process is just not clear. So whoever opens that email sends the check and does not pass it to some higher management to get approval because it appears to have already been approved. It's the same thing as these logic things. If you just have a confusing bureaucratic structure where people aren't really sure what to do or who to ask, then they will be tricked into doing bad things. So you have to have a clear process. And so you have to have clear comments, clear flow diagrams. You know what's happening. You know what components are for. This is a tall order, but this is very similar to achieving compliance with a standard. You actually have to be documented well and organized well, as opposed to the way most companies are. They're just a startup. They hire 3 or 4 people. They write a bunch of junk. Some of them leave. They hire more people. They just pile more and more junk on top of it all until they've got a mess. Nobody really understands it. And you just try to keep it working to get buzz. But in order to achieve compliance and move from sort of a chaotic startup phase to be a mature company phase, you have to clean up and organize and put in all the irritating bureaucracy and rules so you actually know what's going on. So it's the same thing. You have to have a security review and consider all the cases. In reality, I've been told by many people in the business, what I've certainly seen myself as true, is nobody will ever do this preemptively. The only thing they will do is when they get hacked, then they'll try to do it after the fact, except for compliance. This is why I'm pretty fond of compliance. If you want to get a contract with a big government agency or big corporation, they will say you have to have FIPS compliance or something like that. And then you have to actually clean up your act. And it's possible that you might even be doing that before you got hacked, which would be a great thing. Just basic tidiness and organization is the #1 predictor of security. That came out a couple of weeks ago. They did a study of security flaws, and they found that the #1 predictor of security flaws was not the training of your programmers or which product you used. It was how confusing your company was. If the hierarchy of who the boss is and what your job is and who do you ask, if that was clear, you were much more secure than if you have a bunch of people that don't really know exactly what they're supposed to do, what they're allowed to do, who they should ask. That's what causes security problems, is just disorganization, which makes a lot of sense. And that's what compliance addresses primarily, is bureaucratic organization. Anyway, so that's all the 129S I plan to cover tonight. But the thing I thought I'd mention, which is what I've been focusing on, is the COBOL CTF. For some reason, many people want to use COBOL. It's coming out again. I don't know if there are actually jobs in it, but there have been several people calling for it. So I wrote a COBOL CTF, and this is what I've been doing this week. So it's worth extra credit if you want to do it. I put it here on my page. You go to my homepage and go down to the GrimCon, which is next week. They are perhaps going to approve this as part of the con. I don't know. But anyway, I wrote it here, and it's worth extra credit in this class and any other if you're interested in a blast from the past. COBOL was, I believe, the second computer language ever written based on an idea from Grace Hopper Fortran was the first, and that's what I learned on. COBOL was the business language, which I didn't use at the time, but you can totally install it on a cloud Linux server like the one we're using, and you can learn how to write COBOL. And this is the way programming was a long time ago. And the reason it matters, I put a couple links here, is that there are many, many machines still running COBOL. It's not gone at all. And it's very hard to find COBOL programmers. So, because most colleges quit teaching it 30 years ago, thinking it was over, but it's not over. So anyway, you can learn to write some programs. So I'll just go up here and see what I've got. I've got the hello, I think. Yep. Yep, this is the old-fashioned COBOL, the way it originally was. COBOL is so old, it was originally to be put on holograph cards. So you would print this on punch cards, and every line would have to start with a 6-digit number. The 7th digit would have a comment mark. Anything there meant this would be ignored. And then you had commands over here that had to be indented in certain ways. More modern versions of COBOL no longer enforce this because they're entered at terminals instead of this. And I think that's the hello world. COBOL. Yeah, this is the more modern version where you don't need to have these line numbers everywhere and such. But the COBOL uses complete words without abbreviations. That was Grace Hopper's idea. You're going to have a thing called procedure. When you print something, you call it display. You don't have any abbreviations or code words. You have real English words. You put a period at the end of each sentence, like you would in English. The idea is to make it look like English. And so this is how you print something. That's how you stop. And you can do stuff. So there's hello world. If you go down here, there are various challenges. Here you can define variables. You have to have a data division to define variables and a procedure division to make your code. And so in your data, you have a picture of the variable. So this variable is called name. This variable is called number. This is a 20-letter string. So it's A, up to 20 things like A, and this is a 5-digit number. This is what caused the Y2K problem. In COBOL, you don't define variables like integer or float the way you do in the much later language called C. You define them the way they are going to print. Everything is line. So if you define this is a 5-digit number, and that's it. It just has that many digits. And it's all in base 10. There's none of this binary stuff. So in the 70s and 60s, people wrote code, and they put the year in as a 2-digit base 10 number. That's why we had the Y2K problem. When that went from 99 to 00, it thought it was 1900 instead of 2000, because the fundamental problem, which is why I made this CTF, is everybody thought COBOL would be gone in 10 or 20 years. And it isn't gone at all. It's still here 60 years later, or maybe 70 years later. So it is amazing. And so a lot of the world is really running on this thing. So it's an interesting thing to learn. I'm not saying you're going to get a job programming COBOL anytime soon, but if you are interested, you might want to learn it. And it does help me understand the way I program. I've had students get disgusted when they see my code, and I realize I'm coding the way I learned to code in the 70s with Fortran. That's what's going on. This is the way coding originally was. Modern code has all these fancy techniques, and I still code this really old-fashioned way. Anyway, so that's a CTF you can do. A few people are already doing it. I know one of them is actually one of my students. Kay is, I think Kyle might be too. Anyway, so people are doing this, and there may be more people going. I see Liz is moving up. Anyway, so if there are any questions about anything, let me know. I'm going to stop the recording, but I will leave the share on for a while because